Hello everyone, and welcome to my YouTube channel. So, my name is Maroon, and I am 20 years old. I am studying physics engineering at Polytechnique Montreal. I am trying to improve my learning because I want to become a full-time educator. Now, this has always this has not always been my dream, but ever since I entered university, I have discovered the joys of teaching. And also, I've discovered the horrors of the educational system and the challenges that come with learning for all people, not just uh, not just me, but everyone, even the professionals, even those that are good at learning. So my goal is actually to be a professional problem solver, and I would like to specialize myself in pedagogy, which is the actual industry of teaching, learning, and improving educational systems. And so my approach to this is to actually become a professional problem solver. How do I become a professional problem solver? Well, that is where the idea of the polymath comes in. So, the polymath. Now, what does that look like? A polymath. A polymath is someone that is capable of becoming an expert or very close to an expert at multiple fields. So you can be uh, great at biology and also um, physics. Then we have engineering. We might have a bit of um, storytelling, and that gives us a polymath. Quite lovely, eh? And why do we want to be a polymath? Well, what's the point? That, well, being a professional problem solver, that's not really a job, right? Usually researchers are professional problem solvers. They spend their whole life on a single problem, a few other problems, and they try to solve them, and each one specializes in something. And we have learning programs, learning educational programs. However, very few explore the polymath approach, the approach of learning to map. So my goal is to map problems and solutions. So what does that mean? I want to map the physics problems, so problems that come from, for example, physics, and find their equivalent in education. A sort of abstraction of problems and solutions in different fields. And then the, the problems have solutions, and so we might be able to map solutions to those problems. So that's the motivation. So in education, I will have solutions that are novel, and that is why I am studying physics engineering. Now, for those who don't know, physics engineering is the study of very small things. And throughout this YouTube channel, what I will be doing is documenting my journey in learning physics engineering. I want to see results, and I want to experience failures because there lies the treasure. and it keeps improving and then downgrading. And I want to explore this process, and I don't want it to be in the background. I want to have external help, experts, non-experts, opinions. This is all because I want to create a more interconnected framework. The idea is, if you start with a problem or solution and explore different ideas and how they relate to each other, and then you might say, well, this one is actually a bit more important in the case of this problem and has a bigger impact than the others. Well, you might end up having a clearer vision and a path that is actionable to create a solution. And to achieve this, I'm gonna need a lot of work, a lot of resources, and a lot of creativity. I am basically building my creativity. Now, how will I be practicing my creativity and my learning processes? I will be building schemas of ideas, uh, and I will improve their interconnections, and I will be documenting it on Obsidian. And you already have access to my Obsidian Vault. Online, I will be publishing for each subject the ideas that I'm learning. I will try to put as many sources as I can, professional or not. These are how I am basing my learning. And I would love for you to flag any mistakes you find or any problems you might encounter. This is an open source project. This is a project of mine to improve my learning and to help you guys also improve your learning if you would like that. So I will be practicing learning. So schemas, I want to be able to link them, make a document out of them. I want to work them out on projects. The projects will be mainly in robotics and biomedical engineering. So we will be working in biomedical engineering. I am on a robotics team at my university. And in this university, we are trying to work on a robot arm with 6 axes of rotation that is capable of hearing a command and applying it to the user. It is very useful in many settings, including libraries for people that have amputated arms or that are in need of special care. And also, I want to explore some unconventional routes, like linguistics. Because to me, linguistics is just another form of logic, and it is a language. It's the abstraction of language. And as you've seen before, my whole point is to map problems, and that takes a language framework. So if I want to map problems, I'm going to have to speak that language to understand how these languages translate to these other languages. And to do that, I'm going to be an expert at modeling problems and solutions. And that is why I am working right now with a team in my university as well in mathematical modeling. Now, this is all great, but I need a road plan. So here's the road plan. First of all, I will be finishing the I Can Study program. I will have a link in the description. I highly recommend this program. This program is made to teach you how to become a self-regulated learner. And this is cutting edge science in learning. It started in 2020. I haven't seen any program more complete and well documented with the actual scientific papers. Uh, So I will try to complete the I Can Study program. I will be calling it ICS, the ICS program, to become a self-regulated learner. This is the first step to improve my learning. I will also be evaluating the pros and cons of my journey and how I am improving. I will also look into um, Scott Young, who wrote Ultra Learning. And eventually I will look into more of these learning uh, theories. However, the most important part in learning is practice. So we want to practice. I need to practice extensively because the theory is great. It helps me understand. It helps me create a framework. But the practice is the actual skill. Okay, this is how to improve your skill. You have to practice. It's a skill. Learning is a skill. And so we have to practice on our projects. And slowly but surely, these projects are going to encompass engineering, mathematics. I'm talking pure mathematics and applied mathematics, computer science. I'm also going to be working with languages. I currently speak 5 languages, which I do not speak as cleanly as I would like. So amongst these 5 languages, we have French, in which I am native, uh, Lebanese, I am native as well. We have English, almost native. You can feel the accent. Sometimes I lose my words, so English is probably C2 here. So this is C2 as well. This is 2. Literary Arabic, so standard Arabic. And that would be around B1, if I want to be honest with myself. German, also B1. Took 8 years of German. And of course, I will be doing maybe a documentary or a review on how I taught myself Italian in 2021 to a level of B2, B1, B1, B2, depending on how much I practiced. And I taught myself these things. And they are not clean. They are not clean. However, these have helped me tremendously improve my visualization of how things map to each other. And I will explore philosophy eventually with the addition of linguistics. Now, obviously, this is too much and I don't have time, but this is part of the journey. First of all, we need to become self-regulated learners. This will make me a much more efficient learner, which will help me improve my problem-solving skills and how to learn to connect these different fields that are seemingly unrelated and yet so intertwined. And, oh, of course, I forgot biology, because without biology, how am I going to understand the human being? And within biology, I'm looking into neuroscience, but also we are looking at within philosophy, and this is kind of like if philosophy and science had a child, well, they would have psychology. Now, it's a bit chaotic. However, now you can see this, this here, this is what we're working on, okay? We want this to amount to educational hardware. hardware, software, and systems. So I want tools that help in education. I want I want the mechanical tools and the actual programs. I want systems. I want systems that are, this is very important, ta tailored. Tailored. We need systems that tailor to the learner. Eventually, we might incorporate neurodiversity. And so we want to incorporate neurodiversity as it does this change in the mind gives a unusual outcomes. And these unusual outcomes, these are the treasures of us human beings. We need to treasure them. Every mind has its own way of contributing to the problem-solving process of learning. And why? Why? Well, I will tell you why. Because we have a will, and the saddest thing is when our will is lost to confusion and to fear. I want people to have the tools to execute their will. Okay? I'm gonna finish with a few projects that I have started and that I have not finished. Yeah, I tried to do a pulse oximeter. Uh, I will look into that eventually. Maybe a tutorial, maybe a review of how I learned it and why it didn't work, what worked. I also started a teaching slash coaching program. And I would love to have volunteers that will let me, try to build a roadmap for them. So if you lasted this long in the video, props to you. That's first of all. You're the real ones. And if you are interested, we can build you a roadmap. Of course, it's free. We are learning a roadmap that will be customizable through time. So we adapt it to you. So this is not an optimal solution, but rather a good enough approximation. We're looking for a good, approximate, practical solutions. So thank you all for listening to me. Really appreciate it. And don't forget, there's a link for the Obsidian. You can look into my notes. Please read the disclaimer. And yeah, I'll see you next time.